Welcome to a lesson with Dr. Powell. We're going to look at a method or a way of thinking about how we can optimize, maximize, or minimize a function subject to a constraint. Sometimes this is called the method of Lagrange multipliers. So first of all, let's suppose that we have some kind of function that we want to optimize. And I'll just make it a two-variable function for now. Z is equal to fxy. And suppose that we have some level curves drawn in the xy plane that correspond to different levels, like z is equal to 1, z is equal to 2, and so forth. Okay, so we have some level curves. Now let's suppose that our constraint is we want to maximize this on a path. Suppose I draw some kind of a path. Comes through here. Okay, all right. So I have some kind of curve C that's kind of wrapping itself around here somewhere and wrapping itself around. So let's suppose I want to find the maximum value of this function on this. Now you can kind of think now, at least maybe locally. Now, if the curve C is cutting right through a level curve, that means that it's increasing in, that means the output of the function, the z value, is increasing or decreasing in value. So when is it momentarily stabilizing for a maximum or a minimum? When precisely this idea happens. In other words, the curve kind of wraps around and just tangentially hits a certain z level or level of z and then kind of backs down, kind of on the same side, meaning that it's tangent. Okay, so when the curve actually ends up being tangent to a level curve. Now, another way of saying that is if the gradient of the function f, which is perpendicular to the level curve, if that's parallel to some kind of gradient, if c actually was a level curve of some function, then what we want to know is we want to know when the two are parallel. So when so let's suppose c is a level curve to some function g, then when this is parallel, so delta g and delta f are kind of parallel, meaning that there's some kind of multiplier between them, then we're good. This type of thing is called a Lagrange multiplier. Normally we might write it the other way, but either way is fine. Delta f is equal to lambda delta g. We just need them to be scalar multiples of each other, where lambda is a Greek letter and it just means scalar, so they're parallel to each other. Maybe we'll take that form down there. Okay, so that's kind of the idea. All right, so we're going to have the next video, we'll actually give an example where we use this technique and find where a function is optimal based upon this parallel idea. Thanks for watching.